Assalamu alaikum. Welcome to our next lecture, lecture 3 in the Fine-Tuning of the Universe series. In the previous two lectures, we defined fine-tuning and gave an introduction to why this topic is so important for us as people of faith and as people interested in science. Now, let us actually begin the science. And when we talked about physical laws, we said that we need to consider multiple aspects. One is the form of the law. A second are the constants of nature that go into the law. And a third are the initial conditions under which these laws are applied or through which they help events in the physical world unfold. So we will begin with some of the best examples of fine-tuning, and these are initial conditions of the Big Bang. And we will go into some detail, and we will follow Albert Einstein's maxim that things should be made as simple as possible, but no simpler. And so I hope that the level of detail is not too much and not too little. So we begin again with the Big Bang. And I've shown this slide previously, and it is now essentially unanimously accepted among scientists, cosmologists, physicists, etc., that the universe did have a beginning, and that this beginning was in the form of this tremendous explosion known as the Big Bang. And before we move on, I just want to reflect this in the verse of the Quran from Surah Al-Anbiya, because really before the 1960s, the notion was that the universe, number one, was not created, it was eternal. And then even among people of faith, there is perhaps some notion that things are created separately and piecemeal. The sun is created, other stars are created, the earth is created, each individually. And the Quran is here telling us, أَوَلَمْ يَرَى الَّذِينَ كَفَرُوا أَنَّ السَّمَاوَاتِ وَالْأَرْضَ كَانَتَا رَتْقًا فَفَتَقْنَاهُمَا. So are then they who are bent on denying the truth not aware that the heavens and the earth were once one single entity, which we then parted asunder? And فَفَتَقْنَاهُمَا has this word here, has the connotation of a violent cleavage. Now, of course, I'm not saying that this verse, is a clear indication 1500 years ago of the Big Bang, but it is something interesting to reflect on as we move forward. A much more precise statement, which I consider clearly one of the scientific miracles of the Quran, is this verse here from Surah Al-Dhariyat. Now, we know that in this explosion of the Big Bang, this was the beginning of space and time, and space began to expand under the energy or force of this explosion. This notion of an expanding universe is something that we have treated in other videos of the Islam and Science series, but I once again remind you that this was an entirely radical scientific notion. It was so radical that Einstein himself, the man who was the master of sort of breaking paradigms and thinking outside the box, was not able to accept it, even though his equations of general relativity predicted it. And it was only when Edwin Hubble, experimentally showed it early in the 20th century that this became accepted. So for thousands of years, the universe was considered static. The Big Bang produces a tremendous expansion of the universe. The universe continues to expand today. And we see the Quran saying this very, very scientifically radical statement, أعوذ بالله من الشيطان الرجيم وَالسَّمَاءَ بَنَيْنَاهَا بِأَيْدٍ وَإِنَّا لَمُوسِعُونَ. and it is we who have built the universe with power, and verily it is we who are steadily expanding it. So, and Muhammad Asad's commentary, he says that the phrase "inna la musi'un" clearly foreshadows the modern notion of the expanding universe, which again, I remind you, at the time the Quran was revealed, this was considered a very radical notion and was against all accepted scientific wisdom. And it took until the 20th century for us to understand the truth of this statement. So now with these Quranic reflections, let us start looking at the situation. So the universe started in the Big Bang. And for this Big Bang to be able to generate galaxies and stars and planets and eventually life, it turns out that very precise initial conditions had to be met. The universe really had to be very fine-tuned. And so the first topic we want to look at is this notion of the expansion speed versus the mass energy density. So as you know, mass and energy cause a gravitational attraction. You know that two masses or three masses or several masses pull on each other and attract each other. So as this universe is exploding outward in the Big Bang and the energy is being turned into matter, you have an expansion speed from the explosion, and this is being counterbalanced by the mass trying to come together under the force of gravity. And it turns out that the expansion speed versus this energy density, this fine balance between wanting to expand under the force of the explosion and the gravitational attraction wanting to contain that expansion, that balance has to be just right to avoid too rapid an expansion, which would prevent any stars and galaxies from forming. If the universe expanded initially too rapidly, matter would have been very, very quickly dispersed, and it would have been too sparse to coalesce into stars and to galaxies. If the expansion were too slow, then the matter would attract itself and the universe would recollapse on itself in a big crunch before stars and galaxies had time to form. So that is the balance we're talking about. And this is shown in this diagram, that here is time, and here's the size of the universe. And here is the universe expanding too fast for stars and galaxies to form. Here, the universe is expanding too slowly and recollapses on itself before stars and galaxies could form and before life could arise. And in this band, it is expanding just right so that stars and galaxies can form. And of course, this picture does not do the situation justice because it seems like there's really quite a bit of room here, a reasonable space between expanding too fast and collapsing too soon for stars and galaxies to form. It's just a conceptual diagram, and we will soon see that this balance is much finer than this conceptual diagram states. And before that, once again, I want to reflect on the couple of Quranic verses that we had met earlier. And so from Surah Al-Rahman, وَالسَّمَاءَ رَفَعَهَا وَوَضَعَ الْمِيزَانَ, and the firmament he has raised, and he has set up the balance. And of course, the balance here means a lot of different things. It is the moral balance, the balance of justice. I also believe, and God knows best, because we're talking about an issue of creation, that it is the physical balance. And one facet of it would be this balance that we're talking about between the universe expanding too fast and too slow. And we will see very shortly how fine this balance is. And that is my understanding, and Allah subhanahu wa ta'ala knows best. And again, إِنَّ كُلَّ شَيْءٍ خَلَقْنَاهُ بِقَدَرٍ Verily, all things we have created in proportion and measure, from Surah Al-Qamar, and let us launch into it and see how precise this balance is and this proportion and measure. So this is from the author, philosopher John Leslie in an essay of his, The Prerequisites of Life in Our Universe. You will find that essay also in his book, Universes. And so let us look at the balance of density then and expansion speed. And so we're quoting from him. And he says, our cosmos was from very early instance expanding at a speed, placing it very close to the line, dividing continued explosion from gravitational implosion. And it turns out that tiny early deviations from this line would grow immensely, so that things had to start off in a very precise way. And the very famous physicist Robert Dicke in 1970 calculated that a 0.1% increase in the early speed would have yielded a present-day expansion thousands of times faster than we find, something that would preclude the formation of stars and planets and life, whereas a 0.1% equivalent decrease would have led to recollapse when the cosmos was a millionth of its present size. Now, this was his calculation in 1970. As science advanced and models became better and calculations became more refined, it turns out that even this amazing fine-tuning was too conservative an estimate. In 1978, he recalculated that a decrease of 1 part in a million in the expansion speed when the Big Bang was just 1 second old would have produced recollapse before temperatures fell below 10,000 degrees. That's not much cooler than the surface of the sun. There would be no way that life as we know it, chemistry as we know it, could have arisen. And all it would have taken would have been a 1 part in a million change to the balance that was set between expansion speed and density. And then equally, a small, that decrease, the universe would have expanded or recollapsed, and the kinetic energy of the expansion would have so dominated gravity that minor density irregularities could not have collected into stars. So if the speed were decreased by 1 part in a million, the universe would have recollapsed. If the speed were increased by 1 part in a million, the matter would have become too sparse to collect into stars and galaxies. Now, Stephen Hawking estimated that the decrease by 1 part in a million when the temperature of the universe was 10 billion degrees, this is 10 to the 10th, would have resulted in the universe starting to recollapse when the temperature was still 10,000 degrees. So this is pretty early in the Big Bang, when the temperature was 10 billion degrees. If the expansion speed were decreased by 1 part in a million, the universe would have recollapsed on itself while its temperatures were still so high at 10,000 degrees. And you know that the temperature of empty space is about 2.73 Kelvin degrees. So as you see, as science progressed, it turns out that the fine-tuning estimates became even more and more finely balanced. And so it is very interesting that changes in the speed of the expansion by 1 part in a million would have precluded the formation of anything resembling life as we know it. That is a very profound example of fine-tuning, and certainly begs the question of how this could have arisen haphazardly or by chance. And looking at it another way, that instead of looking at the speed of expansion, another way of expressing the need for fine-tuning is to consider the density, which of course has to be balanced with the expansion speed so that the universe doesn't expand too fast or recollapse too soon. And again, trying to trace things to the earliest possible times that we can calculate, the so-called Planck time of 10 to the minus 43 seconds. The density would have had to have been adjusted to 1 part in 10 to the 60. So we were talking about the speed being adjusted to 1 part in a million million. Well, the density would have to be adjusted to 1 part in 10 to the 60. That's 1 followed by 60 zeros. So that would be a billion, 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 and then 10,000 of those. Hopefully I said the correct number. You get the point. So that this is the sort of fine-tuning that is needed so that the universe would have the critical density at which space is precisely flat, putting it between the line of collapsing too early and expanding too fast for life to form. And if the calculations are taken at a slightly later stage where we can be more confident because the Planck time is very early and our physics begins to break down, the fine-tuning remains 1 part in 10 to the 55. That is 1 followed by 55 zeros. So much bigger than a billion, much bigger than a billion billion, much bigger than a billion billion billion, and so forth. And so this is again from John Leslie, Prerequisites for Life, from the book Cosmic Coincidences by John Gribben and Martin Rees. Martin Rees is a very, very well-known cosmologist, and John Gribben is a very well-known science writer. And so they say that, so our existence tells us that the universe must have expanded and be expanding neither too fast nor too slow, but at just the right rate. They say that the relevant number, the so-called density parameter, was set in the beginning with an accuracy of 1 part in 10 to the 60. And changing that parameter either way by a fraction, given by a decimal point followed by 60 zeros and a 1, would have made the universe unsuitable for life, and we know it. So if the initial density were changed by this coefficient, not by 0.1, not by 0.01, but by 0.00001, 60 zeros followed by a 1, that would have been enough to render life impossible. And so these are, of course, the same statement. I just wanted to show it to you from 2 different authors. These are very accepted numbers. These are not controversial calculations. They follow from the equations of general relativity. And so hopefully, I don't want to go on too much in this episode, but hopefully now we get a feeling for what we mean by fine-tuning when we start talking about the initial conditions of the Big Bang. So this Big Bang, when we think of an explosion, we think of something messy and haphazard. This explosion had to be extremely finely tuned in just the right way to allow life to happen, and fine-tuning of things on the order of 1 in 10 to the 60, 1 followed by 60 zeros. And we will see that the balance of speed and density is not the only initial condition or the only fine-tuning that had to happen in the Big Bang. The Big Bang also had to satisfy several other fairly amazing conditions, and we will begin looking at those in the next episodes. But I hope, inshallah, that this whets your appetite, and hopefully we will see you for the next episodes in the series. Take care and God bless.